Recall the last time we looked at this particular network diagram, we configured this internal router number 2, and to do this we started with the configuration that we'd saved from internal router 1, and we made the changes that we needed to make to the configuration in Notepad, and then from this laptop through the console cable using a terminal or terminal emulation program on the laptop, we uploaded it into the router and then we tested it. So now let's move another layer to the left and continue our configuration. Now recall, this was what we come up with for the number 2 router config. And here's our 3 interfaces. And if we're looking at the border router, it also has the same 3 interfaces. It's the same setup as router number 2. And I'm going to modify this and then upload it into the border router. Before we do that, let's talk about a couple things here. Recall for this router and this router, the internal routers 1 and 2, I added this statement, and this is what we call a default route. Okay, this says if you don't know what else to do with a packet, and that's what this is showing you here. This is how Cisco denotes any packet. If you have a packet that you don't know what to do with, send it to this address. Now this 10.20.30.5 is actually this one here on this border router. So this is a default route. Now we have the problem here of if all the traffic is being sent to the left here, that's all well and good, but at a certain point you want to be able to go back the other way with traffic. And to get one of these networks to talk to one of these networks is going to be a little tricky. Well, it's not tricky, we just have to add a command. Now, up here, this network can talk to this network without any added commands because they're both connected to the same router, and the router realizes this. But the problem we have here, if we want to go from this network, the 100 network, to the 103 network, there's not a direct connection through a single router. So we have to tell the border router how to get to these networks. And we're going to do that with a static route. And here's how this works. I selected these networks. So this is 192.168.100.0 and 192.168.101.0. I can express those summarized as 192.168.100.023. The default subnet mask here is 24. If I move the subnet mask 1 bit to the left to 23, that effectively gives me one larger network with these 2 networks in it. Same thing down here. Here the default subnet mask is, and this is 255.255.255.0. That's what the 24 is telling us. If I want to summarize these 2 networks here, all I have to do is move the subnet mask 1 bit to the left and make it 23, which would actually be 255.255.254.0. So that's the process of summarization. Now, summarization is actually the opposite of subnetting. If you recall subnetting, you probably did this in your Introduction to Networking course. So this is just the opposite. You're manipulating the subnet mask. So I need to add these routes, or these summarizations of routes, to the border router, so that when a packet comes back this direction, it knows where to send it. So let's look at the configuration of the internal router 2 and see what changes we need to make. Now, before we get very far into this, I want to point out what's going on with these connections here and also this one here. These are connections between routers, and in essence, these connections make their own network, and they need IP numbers. So what I've done here is take the network 10.20.30.0 and subnetted it. So we need 2 IP numbers per network. And recall from your 160 class, your Introduction to Networking classes, for every network, we don't use the .0 and we don't use the all ones. The .0 is the network ID and the all ones is the broadcast. So actually we need a network here with 4 IP addresses, 2 of which we can't use, and the other 2 that we do use. So that's what you see here. By moving the subnet mask, this time to the right, I can split, and this is called subnetting, I can split this 10.20.30.0 into several smaller networks or subnets with 2 usable IP numbers. So that's what you see here, here and here and here. This is just an example of subnetting. Now, does it really make any difference? No, not really. I could have just said, well, we're going to make this connection here, the network 10.20.30. And then this one would be 10.20.40.0 and this one 10.20.50.0. My point is, subnetting is a way to get more usage out of an IP range. Since we're using private IP ranges, we don't really need to go to the trouble, unless we just want to, of economizing our IP number usage. So just pointing that out, I went on and subnetted it just as a kind of intellectual exercise to show you how it would work in the real world. You just use separate, basically Class C addresses in the private range for each of these connections. So now let's look at starting out with the internal router number 2 configuration. What we want to do here is we're going to save this. What we want to do is save as. So let's change the name here to border router config. And I told you last time is I actually like to put the date in here, and it would probably be nice to put a 2026 in there. So I'm going to save this, and then we're going to make changes to this. So let's look at the border router. Now again, it's handy here because the border router has the same interfaces as this router. So a lot of the information we need here is already there. So this interface, the gigabit 0/0, is going to be using 10.20.30.8. So I'm going to change that 10.20.30.8. And we need to make an adjustment here on our subnet mask. This needs to be, instead of a 0 in the last octet, it needs to be 254. No, excuse me, 252. And think about this, 252, let's count from there, 252, 253, 254, 255, and we're out of numbers. But that's 4 numbers. That's the 4 available IP numbers for any network. In this case, it's the network starting at 10.20.30.8. Okay, so we got that. So I'm just going to copy this. And I'm going to this one and paste it. Now, Ethernet, Gigabit Ethernet 0/1 is using 10.20.30.1. So all I need to do here is change that to a 1. And I can move on down here and paste Gigabit 0/2 is using 10.20.30.5. So I change this to a 5. Now, this is my default route. This says if you don't know what else to do to a packet, send it here. We need to change that because now that address is going to be 10.20.30.9. Now in my particular diagram here, notice the border router, and then you've got the internet here. In the real world, this is going to come from this particular address here. It's going to come from your ISP. It's going to be a public address. But for the purposes of this lab, we're going to use private IP addresses and just pretend that there's more computers out here that we're just calling, into the internet for testing purposes. So this is my default route. Now, we have the problem here is, okay, we've got the packets flowing to the right, but what about packets that need to come back in? Or even go from here around back to here, or this way to here. So we need to add something to this border router to tell the border router that there's networks out here, and this is how to get to them. So we're going to add, these are going to be called static routes. Now, there are what are known as routing protocols that you can actually configure on your devices, and this whole process will be negotiated automatically in the background. For example, if we're running one of these routing protocols, this router here would tell this router that it's connected to that, hey, I know about the 192.168.100 network and the 192.168.101 network. That's what I know about. And the same thing happened down here with the 102 network and the 103 network. This router would tell the border router that it knows about these, and then the border router would know about them and where to find them at, how to get a packet to them. So if you're not using a routing protocol, you can do static routes. Now, for inside a company, I personally kind of prefer, unless it's a really complicated setup, I prefer using static routes. I think you just get more control, and you don't have the problem of configuring a routing protocol. So let's look at what one of these would look like. And I've got one over here. I'll copy it in. Copy. So we're going to add it right here. Control V. So here's our syntax. This says if you want to send something to 192.168.100.1 with a subnet mask of 255.255.254, which are these two networks summarized, send it to whatever the next hop address is. Now, we're going to be putting this static route here. The next hop to get the packet to these networks is going to be this, 10.20.30.2. So let's put that in there. 10.20.30.2. And I think I told you this last time. There's nothing magic about these numbers. They're just private IP ranges, and I just picked them out of the air, really. So that is the route summarization for these two networks. And I told you that right here. So the /23, if you express that as a traditional subnet mask, is 255.254.0. So that's where this comes from right here. Now, Cisco is somewhat infuriating. Sometimes it wants a subnet mask. Sometimes it uses a wildcard mask. Just depends. And a lot of times if you're reading literature on this, it'll just say /23. So you see the subnet mask expressed several different ways. And it just depends on the context. So we also need to add a static route for these two networks here, and that's what it's going to look like. So basically what we can do here is just copy this and paste it. Control V. Now this time we need to change the 2 to 6 right there. So traffic destined for these networks, if traffic is here, it's going to want to send it to this particular interface on this router. So this needs to be a 6. So what have we done? We reconfigured all the IP addresses on these routers, and we've adjusted the default route to go this way, and we've added 2 static routes to summarize these two networks and these two networks. So I think we're good here. Let's just save this and select all and copy. And now let's go down here, and I'm going to unplug my console cable there. And by the way, I deleted this, and now I'm in this mode here. If you hit the escape key, it takes you out of delete mode. I'm going to come over here, and I'm going to go back and get myself a console cable. Recall, we connect to RS-232. We go up here and connect to the console, and then go into the desktop and go to the terminal. Take the defaults. Now what you see here is the boot up of this border router. So press enter. Now I think yesterday at some point I changed the name of the border router, so that's why it's already indicating the border router. The EN takes us from user mode basically to privileged exec mode, and do conf T. So now we're in the config terminal. We're at the right place to paste this in. And I was just glancing over this little configuration here. I didn't specify the host name. So, and somehow there's a 0 there, but that's okay. That's a minor thing. So right here, if I right click my mouse and click paste, it enters and runs the commands that I had in my little configuration file. And for some reason it doesn't like IP classless, but if you save a configuration, it's in there. And it could be that this is just at the wrong level to run this. But anyway, if you get an error like that, that just means that command didn't work. But then it goes on and continues processing. So these lines here are talking about changing the state of the interfaces to up. And if you notice over here, these were the red triangles. Now they're green. This one's still red because this one's not up. Okay? So now we're through with this for the time being. Let's go over here and test this out. So by putting in those static routes that summarize these networks, we should be able to go here and ping this computer up here. And we couldn't do that till we added those routes. I should have showed you that first, but trust me on this, we couldn't have done it. So command prompt, so I want to ping 192.168.100.101, and I'm doing this from 192.168.103.102, which is here. So this packet's going to have to travel to the switch through this router, and then using this router's default route, it'll get sent to here, and this router will look at its static routing table and say, oh, that packet needs to go here. And then this router will say, well, I know where that network is. It's connected to this interface, and it'll send it on out. So that's what's going to happen in the background here. So press enter, and it might take it a couple of drop packets to come to an agreement internally how this is actually going to work. And this is all built into the simulation. And sometimes you think it's not going to work at all. And I've actually seen times I had to press the up arrow and run it again. And let's see. Hopefully I didn't make a mistake. That's not looking very encouraging, is it? So actually it's failed, and now I get to do some troubleshooting. So let's go back over here, and I don't need to do that. I can go right here. Let's look at our configuration here. And as soon as I looked at this, I realized that, notice my route summarizations here. I've got when I copied this, I didn't change this octet. So this should be 102. So if I come back here, press enter, get back to the prompt, and if I do another copy and paste, and run it again, notice this time I still got that. Hang on. Let me get my steps right here. So I made the change in my configuration file, or no, I did. I thought I just changed that. Okay. So let's save that. Save. Select all, copy. And I'll go over here and paste. So now we got that. Notice there's my 102, and this line here represents these two networks here. So the moral of the story is you need to be careful when you're copying and pasting. So let's see, this is on the laptop. I'm going to go to this one and run the ping again, and boom, it takes right off. I pointed this out before. Ping is not 100% definitive, but in in cases where it works, it can tell you. Well, a lot about what's going on. And another cautionary tale on this, in this particular situation, I did a lot of copying and pasting because I'm basically lazy, and you will be too. So you always want to carefully check the things that you copy and pasted, because chances are that's where your error is going to be. So we can also, let's try another one here just to make sure it works. Let's go from this network to this network. So let's do a ping from 190, 192, 168. Let's go to 102, 102. Now in this case, the packet's going from here through this router, through this router, through this router, through this switch, and back out to here. Oh, this one. So all three routers are going to be involved in this one. And there it is. Now, and you also need to always check both directions. I went from down here up to here, and then from up here down to here, because it is possible to misconfigure something such that it only works one direction. So be careful of that. So in general, copy and paste saves you a lot of time. Just be careful with it. And I think that's all we're going to do for this video.